Watch this footage closely because your brain is going to try to tell you it's lying to you. A wall of brown water taller than a three-story building comes screaming down a narrow Himalayan valley. It doesn't rise slowly, it doesn't creep, it just arrives. Houses disappear into it in seconds. Trucks get tossed like toys. And if you didn't know better, you'd swear you were looking at a tsunami hitting a coastline somewhere. Except this happened hundreds of kilometers from any ocean, on the border between Nepal and Tibet. And here's the detail that's breaking people's brains. There was no storm, no days of rain building up, no slow flood warning. One moment the valley was calm. Minutes later, it was gone. So what actually made this happen? The real explanation is stranger, and honestly scarier, than almost anyone watching this footage assumes. The morning of August 26th, 2026. The border zone between Nepal's Rasuwa district and Girang County on the Tibetan side. Within hours, footage was spreading worldwide of the Bote Koshi and Trishuli river systems tearing apart hydropower stations, bridges, roads, and entire village clusters. The current toll, over 270 confirmed dead across both countries, with close to 1,500 people still unaccounted for, including a significant number of foreign trekkers who were in the region at the time. Rescue crews haven't even reached some of the cutoff areas yet, so these numbers are expected to climb. When something this violent happens with no obvious trigger, everyone reaches for the usual suspects. A glacial lake outburst, an earthquake-triggered landslide. And for a few hours, that second theory actually looked right. Seismographs did pick up a real signal right before the flood hit. The U.S. Geological Survey's automated system briefly logged it as a magnitude 4.4 earthquake. Then geologists actually looked at the data. That signal wasn't tectonic at all. It wasn't the Earth's plates shifting, it was something enormous hitting the ground from above. Before and after satellite passes from Planet Labs traced the source to the upper valley of a glacial tributary roughly 20 kilometers northeast of the Rasuwa-Girang border crossing. A chunk of glacier and mountainside, ice, shattered rock, and packed sediment. Simply let go, at around 5,200 meters of elevation. That's higher than the tallest peaks in the Alps. It then dropped nearly 1,200 meters down the mountainside. Picture the Empire State Building. Then picture it 3 times over, falling in one continuous collapse. At that moment, there was no river involved yet, and it was already lethal. When that much frozen rock and ice fails on a slope that steep, it doesn't behave like a solid object falling. It behaves like a liquid, shattering, colliding, spreading, but still carrying all that momentum downhill as one connected mass. This is what scientists call a rock-ice avalanche, and it's genuinely one of the most violent natural processes on the planet. It also explains the false earthquake reading. That much material slamming into a valley floor sends shockwaves through the ground that look almost identical to a shallow quake on a distant seismometer. The mountain itself was the earthquake. Here's where most explanations stop, and where the real story actually starts. A rock-ice avalanche on its own doesn't usually travel 30 or 40 kilometers. Physics says it should slow down, spread out, and stop somewhere in the upper valley. This one didn't stop. And the reason has a name: entrainment. As the falling mass roared down into the valley floor, it didn't just slide over the top of everything in its path, it plowed straight through saturated riverbed sediment, meltwater ponds, and loose glacial debris. And it picked all of it up. Mud, boulders, water, broken ice, all of it got folded into the moving mass. That mixture is a completely different beast from the original avalanche. Geologists call it a debris flow. Something with roughly the texture of wet cement, moving at highway speed, and carrying boulders the size of cars inside it. This is the detail almost no one reporting on this got right. The flow didn't get weaker when it hit the river. It got bigger. It absorbed the river. In events like this one, research shows the water and wet sediment scooped up along the way can actually add more liquid volume to the flow than the glacier ice that started it. In other words, what's in that footage isn't a river that overflowed. It's a mountainside that kept consuming everything in its path until it became a flood. People online keep calling this a tsunami, and it's easy to understand why. That near vertical wall punching through buildings looks exactly like one. But a tsunami is a different mechanism entirely. In a tsunami, something displaces a body of water, an earthquake, an underwater landslide. and the water carries that energy forward as a wave, while the water itself mostly stays where it was. That's not what happened here. In this valley, the boulders, the mud, the shattered ice, and the water were never separate from each other. They were all part of one moving mass traveling downstream together. It wasn't energy passing through the river, it was the material itself relocating. That towering, near vertical front you see in the footage is simply physics sorting the debris flow by weight. The heaviest boulders and rock concentrate at the leading edge, forming a dense battering ram, while the thinner, muddier slurry behind it keeps shoving that front forward. Think of it less like a wave and more like a bulldozer with a river built into it. There's an open question researchers are still working through. Did the initial avalanche briefly dam the river? In a valley this narrow, millions of tons of ice and rock hitting the floor can temporarily block the channel. Water backs up behind that blockage until it fails, all at once, releasing everything in a single violent pulse. That theory would explain something that's hard to account for otherwise. One downstream gauge recorded the river rising nearly 9 meters, about 30 feet, in just half an hour. That hasn't been officially confirmed yet, but it lines up with how similar Himalayan disasters have unfolded before, and it matches the timeline of when the surge actually reached people downstream. Best current estimate, the glacier failed at roughly 8:37 a.m. local time. By around 9 o'clock, the river was already rising catastrophically. Communities near the border had at most a few minutes of warning between the collapse and the wall of debris arriving. And there's a specific systemic reason for that. Flood warning systems built for mountain regions are designed around rainfall data, upstream river gauges, and weather forecasting. They're excellent tools for storm-driven floods. None of them are built to detect a glacier spontaneously collapsing on a perfectly clear morning 20 kilometers upstream across an international border. By the time downstream sensors picked up the rising water, the debris flow had already reached them. Several of those monitoring stations were destroyed by the very flood they were supposed to be tracking. That's the uncomfortable truth sitting underneath this disaster. The region's warning infrastructure was built for yesterday's threat. The danger isn't just the monsoon season anymore, it's the mountains themselves. So why did this section of glacier let go in the first place? Satellite data shows a noticeable amount of snow vanished from that exact area during an unusually warm stretch in the days leading up to the collapse. Rapid melt like that can send water deep into cracks in the rock and ice, or straight down to where the glacier meets bedrock, cutting the friction that was holding the whole mass in place. Zoom out, and this fits a much bigger, much more worrying pattern. Glaciers across the entire Hindu Kush Himalaya region have been losing mass for decades. The permafrost that's acted like natural cement inside high-altitude slopes for thousands of years is thawing. Rock faces that have stayed frozen solid since before recorded history are starting to come apart. And this isn't even the first warning from this exact river system. In July 2025, an outburst flood down this same watershed destroyed the Nepal-China Friendship Bridge at Rasuwa-Girang and killed more than a dozen people. That bridge had barely been rebuilt. This time, the same river did it again, bigger, faster, and with a far higher cost in lives. The International Center for Integrated Mountain Development has spent years warning that glacier collapses, landslides, and floods across the Hindu Kush Himalaya are becoming more frequent and more severe. What happened on August 26th is precisely the kind of event they said was coming. It is very unlikely to be the last. Strip away the footage and the fear, and here's the actual sequence. A section of mountainside failed under its own weight. It fell over a kilometer, hit the valley floor hard enough to be mistaken for an earthquake by instruments on the other side of the planet, then absorbed an entire river system on its way down and turned into a fast-moving debris flow that tore through populated valleys for dozens of kilometers. What you're watching in that footage isn't a flood in the traditional sense. It's a mountain that progressively turned itself into one. But behind the geology, there are real people, families who had no reason, on an ordinary Wednesday morning, to expect their valley was about to be erased. Hundreds still missing. Entire communities now rebuilding from nothing. As fascinating as the science behind this is, it's worth sitting with that for a second before we move on.